Welcome to the DIY Honda Garage channel. The Honda CR-V 2023 Plus may experience a DTC P0108, which indicates a high voltage condition in the Manifold Absolute Pressure (MAP) sensor circuit. The MAP sensor is crucial for monitoring the intake manifold's absolute pressure, which in turn aids the engine control unit (ECU) in optimizing the air-fuel mixture for efficient combustion. The sensor is typically located on or near the intake manifold, making it easily accessible during inspections. If the output voltage from the MAP sensor exceeds a predefined threshold of 4.49 volts, the Powertrain Control Module (PCM) recognizes this anomaly and logs a Diagnostic Trouble Code (DTC). This code will generally illuminate the check engine light on the dashboard, as it prevents the vehicle from operating under optimal conditions, potentially leading to reduced engine performance and increased emissions. Regular diagnostics should be carried out to ensure the proper functioning of this system. The DTC P0108 occurs when the MAP, Manifold Absolute Pressure sensor, outputs a voltage higher than 4.49 volts, flagging an abnormal situation in the circuit. The MAP sensor plays a vital role in measuring the pressure in the intake manifold, providing critical data to the PCM, Powertrain Control Module, to adjust engine parameters. This sensor is usually located on the intake manifold itself, making it pivotal for responsive engine performance. When the PCM detects a reading above the normal threshold, it triggers a fault code. This code serves to alert the driver that further diagnostics are needed to investigate the underlying causes of this voltage issue. Notably, without a functioning MAP sensor, the vehicle may experience performance degradation due to incorrect fuel mixture adjustments. Therefore, pinpointing the issue is essential for safe and efficient operation. There are several probable causes for encountering DTC P0108 in the Honda CR-V. A faulty MAP sensor is the first suspect, as wear and tear or internal failure could cause it to produce high voltage readings. Another potential cause is an open circuit in the wiring connected to the MAP sensor. Damaged or corroded wiring can interfere with the sensor signal to the PCM. Finally, a malfunctioning PCM can also result in erroneous voltage readings if it fails to process normal signals correctly. Each of these causes must be explored in detail to determine the precise issue at hand. Conducting a thorough inspection of the sensor, wiring, and PCM connectivity is essential to accurately diagnose the problem and prevent unnecessary component replacements. Symptoms associated with DTC P0108 can manifest in multiple ways. One of the most immediate indicators is the illumination of the check engine light, signaling a need for diagnostics. Drivers may also notice poor engine performance, which could manifest as sluggish acceleration, rough idling, or stalling. The vehicle may struggle to reach optimal speeds, making it challenging to operate safely. Another significant concern is increased emissions. A faulty MAP sensor can lead to an incorrect air-fuel mixture, which can produce higher levels of pollutants. Monitoring these symptoms closely and responding promptly can prevent more severe issues from developing, as prolonged exposure to engine performance problems may lead to further mechanical failures. In the first step of troubleshooting DTC P0108, begin by turning the vehicle to the on mode without starting the engine. At this stage, the use of the HDS, which stands for Honda Diagnostic System, is integral. This system allows for real-time diagnostics and monitoring of various engine parameters. Check the MAP sensor voltage reading displayed on the HDS. If the reading exceeds 4.49 volts, the failure has been duplicated, confirming an issue within the MAP sensor circuit. This step serves as an initial confirmation of the fault, as it directly correlates the symptom to measurable data. The importance of this step lies in its straightforward nature. If everything checks out, further inspections can proceed confidently. Moving on to the second troubleshooting step, begin by disconnecting the map sensor connector, 3P. This disconnection is crucial to isolate the sensors from the circuit entirely. Next, jump terminals number 1 and number 2 on the map sensor connector using a jumper wire. This action simulates a closed circuit, and it allows technicians to analyze the map sensor's behavior under controlled conditions. After making this connection, turn the vehicle to the on mode again. The HDS should be checked to observe the map sensor voltage reading now. Ideally, the voltage should be less than 4.49 volts, indicating that the sensor is not the source of the problem. If the measurement is still high, the issue lies with the map sensor itself. In the third troubleshooting step, inspect the PB power supply B and SG1 signal ground 1 wires for open circuits. Before disconnecting the PCM powertrain control module connector, jump the SCS service check signal line with the HDS and allow a waiting time of more than 1 minute for the system to stabilize. Afterward, disconnect both the map sensor connector and the PCM connector E, ADP. Conduct an open wire inspection between the map sensor and the PCM using the conditions listed in the service manual. Normal conditions dictate that there should be less than 1 ohm resistance for both the PB and SG1 lines. If any faults are detected during this inspection, it suggests that an issue exists in the circuit, thereby pinpointing the fault outside the map sensor itself. In the final troubleshooting step, focus on inspecting the PCM if prior tests indicated normal conditions for the map sensor and wiring. If everything else checks out, but the high voltage condition persists, it's probable that the PCM itself is malfunctioning. This module is responsible for interpreting sensor data and adjusting the engine's parameters accordingly. Therefore, any errors in the PCM can lead to incorrect voltage readings from the map sensor. Verifying that the PCM is functioning correctly may involve further diagnostic checks specific to the module. If the PCM is determined to be the source of the fault, replacement may be required to resolve DTC P0108 definitively. After successfully conducting repairs based on the earlier troubleshooting steps, it is vital to perform final repair verification for DTC P0108. Start by clearing the Diagnostic Trouble Code from the system using the HDS. This action resets the vehicle's fault memory and allows you to monitor current data without interference from previous error codes. Following this, test the vehicle's performance through a short drive. Pay attention to engine responsiveness, the operation of the check engine light, and any related symptoms that may have been present. This step confirms that the repairs were effective, functioning correctly under operational conditions. After ensuring that the vehicle is performing adequately, you can be more confident in the resolution of the issue. To minimize the risk of encountering DTC P0108 in the future, proactive preventive maintenance is key. Regularly check the map sensor for signs of wear or damage, as this component plays a pivotal role in measuring intake manifold pressures accurately. Additionally, it is crucial to inspect the wiring that connects the map sensor to the PCM. Look for signs of fraying or corrosion, which can interfere with the sensor's readings. Routine inspections not only promote the longevity of your vehicle's components, but also enhance overall engine performance and fuel efficiency. Facilitating regular checkups through a scheduled maintenance plan ensures that any potential issues are detected early and addressed promptly. This preventive approach can save time, costs, and unnecessary repairs down the line. In conclusion, understanding DTC P0108 is crucial for maintaining the Honda CR-V's performance. Recognizing the symptoms, such as the check engine light and poor engine performance, can help you diagnose issues promptly. Knowing the specific causes, including a faulty map sensor, open circuit wiring, or PCM failure, allows for targeted troubleshooting. Following the structured troubleshooting steps thoroughly ensures that no component is overlooked. Additionally, implementing a regime of preventive maintenance, including regular checks on the map sensor and associated wiring, enhances vehicle reliability. By maintaining awareness of these factors, you can ensure your vehicle operates efficiently and address any issues before they escalate into more significant problems. Please like and subscribe to the channel. See you next time.